Alright, so your test is tomorrow on 6.1 through 6.3. Let's take a look at the review. So tell whether the function represents exponential growth or exponential decay. Explain your reasoning. So looking at number 1, do we have growth or decay? Growth. Because our base is greater than 1, we have growth. What about number 2? Decay. What about number 3? Growth. And number 4? Decay. Awesome. So when our base is E, remember we have a different criteria for growth and decay. So if our x is positive, we have growth. If our x is negative, we have decay. So for number 1 and 2, it's different than 3 and 4 because we have that E in our base. So for 3 and 4, we have to look at whether x is positive or negative. All right, number 5. How do we simplify this? What do we do to combine them? Awesome. We add the exponents. So 8 plus 4 is 12. So e to the 12th power. Number 6. We want to combine our coefficients and then combine the variable with their exponents. So how do we combine 15 over 3? What does that simplify to? 5. Perfect. 15 divided by 3 is 5. And then what do we do when we divide? How do we combine those? What do we do with the exponents? Subtract them. So what's our exponent on the e on the bottom? It doesn't have one written there, but what do we know? Awesome. It's 1. So it's 3 minus 1. So 5e to the 2nd power. Number 7. We have 5e to the 4th, e to the 4 times x power cubed. So what do we have to do to simplify? Distribute the 3. So that 3 is a 5 cubed and e to the 4x cubed. So 5 cubed, e to the 4x cubed. What is 5 cubed? 125. So remember, it's 5 times 5 times 5, which is 125. And then what do we do when we have an exponent raised to an exponent? Multiply them. So this is e, and what's our power here? 12x. Perfect. Awesome. Let's look at 8. What do we do here? How do we simplify? The e and ln cross out. So then what are we left with? 9. So just remember that ln is the same thing as log base e. So when you have e and log base e, since your bases are the same, they cancel. So this is important to know for your test tomorrow. ln is log base e. Number 9. How do we simplify this? Awesome. We want to make this 49 look like a 7 because then it'll cancel out with our log base 7. So we want to get 49 to be 7 with some exponent up here. Perfect. This would be 7 squared. So we're going to change this 49 to be 7 squared. So we have log base 7 of 7 squared. And what do we do with that x there? Do we add it, multiply it? What do we do? because we still had an x up here. What was that? It's getting multiplied, but we just keep it next to the 2. So now what happens? Log base 7 of 7 cancels, so what are we left with? 2x. Okay, number 10. What do we do here?
Take the 81, 3, and then 4 to the negative 2x power.
So we want 81 to look like 3 with some exponent. What did we say that exponent's going to be? 4. Perfect. So we can change this 81 to be 3 to the 4th power. So this is log base 3 of 3 to the 4th power. And what do we do with that 2x, negative 2x there? But how do we combine them? Can we simplify that? Multiply them. So log base 3 of 3 to the negative 8x power. Can we simplify this more?
No.
Does anything cancel?
Oh, sorry. Yeah.
Yeah. So the log base 3 of 3 cancels. And what are we left with?
Negative 8x.
Negative 8x. Let's look at 11. So we have to rewrite in exponential or logarithmic form. So it's given to us in log form. We got to write it in exponential form. So what's our base going to be? What do we start with? 4. Our base always comes from the base in our log. And then what's our exponent on 4? 5. And then what's that equal to? 1024. So this is our exponential form. Just remember, what's on the right goes to the left, what's on the left goes to the right. So you switch positions. Number 12, what's our base? 1/3. What's our exponent? Negative 3. And what's that equal to? 27. Awesome. 13. So here it's given to us in exponential form. We have to put it in log form. So what do we start with for log form? Log. We always start log form with log. And then what's our base? 7. What number comes next? 2,401. And what's that equal to? 4. Awesome. So this is our base. What's on the right goes to the left. What's on the left goes to the right. And 14. So we start with log. What's our base?
4.
What comes next?
0.0625.
0.0625. And what's that equal to?
Negative 2.
-2. Awesome. Any questions on these? All right, for 15, 16, and 17, we're just putting it into the calculator. So what do you get when you do log of 45 in the calculator? 1.653. Everybody agrees? Anybody get anything different? Awesome. 16. What'd you get when you do ln of 1.4 in the calculator? 0.146. Everybody agrees? All right, let's do it. I got 0.336. Is that what you got? Okay. So just be careful when it tells you ln, make sure you're using the ln button. It evaluates it differently than the log would. So just keep that in mind. All right, 17. How do we put this into the calculator? Log of 32 over the log of 2. What'd you get? 5. Perfect. We could also do this by changing 32 to look like 2 to some exponent. So we would say 32 is equal to 2 raised to what power? 5. So this would be log base 2 of 2 to the 5th power. Log base 2 of 2 cancels, and we're just left with 5. So 2 different ways to do this one. You can put it in the calculator using this way, or do it by hand this way. All right, let's look at 18. So for 18 and 19, we're graphing. We just have to graph the function. You don't have to graph the inverse. So for our exponential function, we need 3 points for our graph. For log functions, you only need to plot 2 points. So what are 3 numbers we can plug in here for x?
1, 0,
Negative 1, 0, and 1. Perfect. So we have 1 over 9 to the power of negative 1. What happens when we have a negative exponent? We just flip it. So it's 9 over 1, which is just 9. So on our graph, we're going to go to the left 1 and up 9. So there's our first point. Next, we plug in 0. What is 1 over 9 to the power of 0? 1. Anything to the power of 0 is 1. Got to remember that. So we stay at 0, go up 1. And then let's plug in 1. We have 1 over 9 to the power of 1, which is 1 over 9. So we go the right 1 and up 1/9. So we're barely off the ground there. Now we just connect our dots. It's important that you guys know the shape of an exponential graph and a logarithmic graph. Your graph is not going to cross the x-axis. All right, next we have a logarithmic graph. So for log graphs, we only have to plug in 2 numbers. What are we going to plug in? 1 and 5. Perfect. So we want to plug in 1, always for log graphs, and then we want to plug in whatever the base is. So we have log base 5 of 1 plus 1. How do we evaluate that log base 5 of 1? So we're just figuring out what this is first. Log of 1 over log of 5 plus 1. What's the log of 1? 0. So this would be 0 over, doesn't even matter because this is going to be 0. So 0 plus 1 is 1. So on our graph, we go to the right 1 and up 1. Put our point there. Next, we plug in 5. So log base 5 of 5 plus 1. What's log base 5 of 5? 1. So we get 1 plus 1, which is 2. So we're going to go to the right 5 and up 2. Then we connect our dots. Make sure you don't cross the y-axis here. All right. 24. So here we have our word problems. You purchase an antique lamp for $150. The value of the lamp increases by 2.15% each year. Write an exponential model that gives the value y in dollars of the lamp t years after you purchased it. So we're using our formula that's a times 1 plus r to the power of t. And we use this one because it's not compounded and it says increases, so it's the plus R, 1 plus R. So we have to find what A is, what R is, and what T is, and we plug them in. So what's our A? $150. A is your starting amount, whatever you start with. So we purchased it for $150. What's our rate?
0.215.
Awesome. We have to move our decimal 2 decimal places, so this would be 0.0215. So it's going to give you the rate in the percent. You have to change it to the decimal. So you just move your decimal twice. And then does it give us anything for T? Nope, it just says T years, so our T is just T. So all it's asking us for is to write the exponential model, so we're just writing the equation. So we got to plug everything in. We have 150 times 1 plus R, so this will be 1.0215 to the power of T. So this is our equation. There's 4 different formulas we have for our word problems. We could have the one we just did, A times 1 plus R to the power of T, A times 1 minus R to the power of T. We have our compounded interest one, which is P times 1 plus N over R over N to the power of T times N. And then we have our compounded continuously, which is our PERT formula, P times E to the power of RT. So we use this one when it's increasing. We use this one when it's decreasing. We use this one when it is compounded. And then this one when it is compounded continuously. So if you're using your notes tomorrow for the test, I would definitely have this written down. All right, let's move on to the next word problem. You deposit $1,500 in an account that pays 7% annual interest. Find the balance after T years when the interest is compounded daily. So which formula are we using? 1, 2, 3, or 4? Does it say compounded continuously? It doesn't say continuously, so we have to use 3 because of compounded. So it tells us that it's compounded, we got to use 3. It would specifically say compounded continuously, then we would use 4. So we use formula 3, which is P times 1 plus R over N to the power of Tn. So we have to find our principal, our rate, our N, which is the number of times per year, and T, which is time. So what's our principal? Our starting amount, what do we start with? 1,500. What's our rate? 0.07. So we just move our decimal place twice, so 1, 2. So it's 0.07. What's our N? Awesome. It tells us daily. So daily means it happens 365 times during the year. Make sure you know how many days are in a year. There we go. And then what's our T? 2. It tells us 2 years. So we plug everything in. We have 1500 times 1 plus r, which is 0.07 over 365, to the power of 2 times 365. So I'm going to find out what my exponent is first. I'm going to do this in the calculator. So what's 2 times 365? All right, so this was 370, or 730. 730. What do we have to do next in our calculator? .07 divided by 365. And what do we get? Something like this. We add 1 to it, so we can just put a 1 up front. It helps if you just leave it on your calculator. That way you don't have to write down everything, because it will be a long decimal, and you want to make sure it's as exact as possible, so keep it in your calculator. Then we raise that to the power of 730. And what do we get? .4 or something, I think. Then we multiply that to 1500, and what do we get? 1725 and what? 0.39. So since we're dealing with money, just round it to 2 decimal places. But make sure when you're working all of this out, keep it in your calculator. So some people are able to put this whole step in your calculator and solve it in one shot, which would be really nice. So just make sure you write down the formula, and then if you put it in your calculator right off the bat, write your answer. So I just want to see your formula, everything plugged in, and your answer. So if you can keep it on your calculator, you don't have to write anything down. Just make sure you write this down, your formula. Next page. We got 3 more problems left. So we have to evaluate the logarithm. Just like before, we could do this 2 ways. We could say this is log of 8 over log of 2. Put it in our calculator, find the answer. What'd you guys get? 3. Or we could change the 8 to look like a 2, so this would be log base 2. What would the exponent on 2 need to be? 3. So log base 2 of 2 to the 3rd power, this cancels, we're just left with 3. So you could solve it either way, whichever you prefer. All right, it's 12. Same thing before, we can do our change of base. So what goes on top? 1 over 36, and then log of 6 on the bottom. We could do it this way, put it in our calculator, or we could say 1 over 36 is 6 to what exponent? What power do we need on 6 to be equal to 1 over 36? Negative 6? It's definitely going to be negative because we want to flip it. Negative 2. Because 6 squared would give us 36. So we could say this is log base 6 of 6 to the power of negative 2. Log base 6 of 6 cancels, and what are we left with? Negative 2. So either way, if you want to put it in your calculator, you can do this, or you can do it. I would probably say this is the long way, but if you want to work it out and do it this way. Or you can do it both just to check your work. All right, 13. So we can put this in our calculator. or you don't even need to if you are a genius and you know what it is. So we would have log of 1 over log of 5. We've done this so many times. What's the log of 1? 0. It doesn't even matter what the log of 5 is. I don't care. So what's 0 over whatever? 0. All right, any questions about your tests tomorrow?